How's that? This is that's not really the reason we started early, but it looks like it's working now. So I guess I'll know in 10 seconds because there's a 10-second delay. But good. The running speed starts out slowly but gets faster each minute after you hear the signal. Ding, a single. Somebody went to PE today. I forgot who you are. I remember you sent me an email. Good, good, good. But if you get a second and you really care about it, log in. Like it says, if you're on your JT account, then you get some extra credit because then I won't have to go figure out who you are. Remove that and all that good stuff. Oh, I need to also check the document camera. Oh, there's my calculator. Sweet. Okay, that should work. Let me just do one of these thingies and scooch that over. All right. Oomph. You can see the red dot. Okay, is it focus? No. Focus. Oh, we got like less than a minute. Okay, go away, calculator. Go away, calculator. Yeah, 10-second delay, give or take. And the equation sheet, well, we'll figure it out. I'm not too worried about it. Wait a minute. It's like all that's showing right now. All right. That was weird. Yeah, I mean, I remember. Okay. So if you're watching now, it's actually time to start. So like I said, hopefully you skipped 5 minutes ahead because now it has been 5 minutes and I would like to we can actually start now. So let's do this. So Martin, what I'm going to have you do then is when I do ask for the extra credit thing, just put your name in there, just to save me like a step. Like I might remember, but I don't know. If you've seen me today, you know my memory. You saw an example of how my memory lasts. It's like, hey, I think I know you. I squint, and it's like, oh, I guess I don't. No, I do, but name and face. Anyway, Martin, yeah, awesome. So we have our Unit 7 test tomorrow. So let's get down to business. I don't want to waste you guys' time. And I just wanted to do this live stream to help you get through this. And like I said, present it in like a slightly different way and hopefully a way that is usable for you. Let's see if I could just click yes. Okay. So in the chat, you can answer if you feel brave enough, but I think you know the answer to this one. What's the flow of electrons called? And I'm not going to use a poll because I want to just kind of like, I want you to just be able to answer in the chat. So the flow of electrons is a current, amperage, resistance, voltage, or ohms. The flow of electrons. And guess what? Any questions you see here are fair game. Maybe not the exact same words for tomorrow's test. I'm not seeing a lot of answers here, but that's okay. Maybe just getting, let's see. I'm just gonna, while you guys are thinking about answering, should I answer? All right, good. Like, good. We got a bunch of people on. That's fantastic. All right, current. All right, I try to make it simple, you guys. It's multiple choice. You could, but you are correct. Yes, it is called current. Yes, you guys could just, if you like to, just put the letter. You could put A, but it is called current. The flow of electrons. Good. So a little definition just to get things out of the way. Good. And by the way, there is a 10-second delay, give or take. So if you have a question for me, I might not see it, right away. Oh yeah, that's fine. As long as I know who you are, that's going to be super helpful. So thanks for asking, Troy, because like I said, I know Martin, everybody knows that's Martin, but so I'm going to ask this question, then I'm going to talk about that. What does a battery or other power source provide? Current, amperage, resistance, voltage, or ohms? All right. So yeah, the reason for the being on your JT account is just to it just makes things a little bit smoother, a little bit easier. There's a little bit more security. Like that way I know I'm not going to kick you out if you're not going to trip any alarms, for example. Awesome, cool, yes. All right. Well, see, your name is right there too. I mean, now if I start to see some weirdo names like, well, I can't even say them out loud, then yes, you guys are correct. Good. All right, voltage. So a battery provides voltage. If you remember, I have shown you this before, or not this exact one, but I've shown you things like this here. here is the battery, this thing right there, right? And the battery is literally like, here, let me, how do I switch to, it's been too long. Tilde, no. I don't want to hit escape because I don't want to end this. Let me switch over to the, I literally just rushed home. I apologize. So yeah, so this right here is the battery. And if you remember from the FET simulation, the FET simulation was pretty good in that it showed you that everything, the wires, everything, all the connections, the resistors, the light bulbs, they all already had electrons, okay, in them. So this is one of the biggest misconceptions, that a battery provides like charge, or the battery provides electrons or something like that. It doesn't. All the battery does is provide voltage, and voltage is just a push for the electrons that are already there. Okay, so just keep that in mind. That's all a battery does, is it provides the push, and we call that push the voltage. Nobody's making fun of you, but yeah, that's okay. All right. For electrical current to flow, which of these are necessary? We'll choose more than one. All right, we need electrical current to flow. All right. What's Martin? You and your questions. Oh, I totally slurped that water. I apologize. So what do you need for current to flow? That's, you know what? I made this, my Google account. Well, actually, I don't even know when I made my Google account, but yeah. I'm glad I didn't get to make a Google account when I was 8. I'm glad about that. Okay, a conductor. Okay, so there are several choices, and these are all correct. Well, the ones I'm going to choose are correct. A conductor, you need, yes. All right, you need, so, okay, amperage is a unit of measurement, okay? This is a noun. Okay, you need a noun. You need something for the electricity to flow through. Amperage is just a measurement, so I don't know if we would need that, right? Resistance, man, if we could, they're working on things called superconductors. They've been working on superconductors for decades, but superconductors are exactly what they sound like. You don't want resistance unless you want resistance. Okay, so if you could avoid resistance, you don't want that. You definitely need voltage, because here you have the verb, okay? The verb is the push. True. Okay, so Danny says, okay, you are not wrong. You are not wrong. But all it says is you just need electric current to flow. It doesn't say anything about it being controlled. But Danny, you are correct. If you want to have a controlled circuit, you are going to need some resistance in there at some point, but just for specifically electric current to flow, whether it's controlled or whether it's not, you just need these two things. You need a conductor for the electricity to flow through, and you need the voltage to push those electrons through. I'm thinking bare minimum. Okay, what do you need for electricity to flow? It's like what do you need for a car to move? You need the gas pedal and the brakes, right? Nobody said anything about controlling the car. Just how do you get it to move? So in this case, how do you get electricity? So you are correct. You are correct. But just to get it to flow, you just need those two things. Charge per second. Oh, another definitional one. Mr. Jaron, what are you doing? Well, you know what? This is one of those ones that you might have missed. Okay, and that's sort of what this is all about. And you guys could put questions in the thing. You could send me questions on a remind, whatever you got. Okay, this is meant to be like a little bit of the basic stuff. Like this is the definition, and it's going to be a little bit of the other stuff too. Okay, so charge per current. Martin, you're going to get banned, sir. No, you're not. You're fine. No, I appreciate you. No, it's good. All right, that's not it either. Charge per second. Okay, if I were to write this mathematically, charge is Q, per second is just per time, and you can, that's a terrible, I'm gonna rewrite that, Q per time. So I'm just gonna, that was badly written. If you look on the equation sheet, if you're not sure, you're not gonna get banned. The equation that goes along with this is I equals Q over T. What is that? That's current. That's literally the definition of current. All right. It's like if you look at a river and the river is flowing by, right? Okay, so there's the river. Here's the water flowing by. How much water is flowing past? That's the current. That's the water current. Okay. How many charge? Hi, neighbor. How much charge per second? That guy's awesome in the middle of the night too, by the way. How much charge per second? That's current. Okay. Charge per current. By the way, if I move on too quickly and we got the like 10 second, 15, sometimes it's a 15-second delay. Thanks, YouTube. But, oh, all right. Somebody just messaged me. I'm not sure if she's on, but if you're on, I will fix that. Okay. So that dink was the sound of remind. I should mute it. So anyway, like I said, if I go too quickly, just let me know. There's a 10-second delay and I'll go back. All right. Which of these makes a good insulator? Choose more than one. Insulator. Okay. I'm going to take another sip of water. Insulator. Insulator. Oh, look, too. I changed my shirt. It says NASA because they flew a helicopter this morning. Well, actually, it was like not this morning, but they released a video this morning of the helicopter flying on Mars. Oh, Martin. All right. Insulators are things that prevent electricity, electrical flow, right? It's the opposite of a conductor. So an insulator is not a conductor. All right. There's a letter missing there. Rubber is a good insulator. That is right. There's two more. And I will say glass, aluminum. All right, no. I thought I spelled it wrong. And plastic. So yes, rubber is a good one because a lot of things are coated with rubber. You have rubber soles shoes, protects you a little bit. But glass and plastic are all. Wood is a good insulator. Yeah, so anything that's metal is going to be a good conductor. So copper, gold, and aluminum, beautiful conductors. They conduct electricity very well. Okay. All right. Moving along. I'm glad you guys are having fun in the comments. All right. Talked about this. Well, wait, hint. Okay. Which wire has the most resistance? If these choices were wires, which would have the most resistance? Now be careful here. It's easy to get these backwards. The most resistance. I thought, should I turn off the emojis? Nah. Why? I mean, it's serious, but there's no reason for us to be so like sad and all that. It's just a test. The most resistance. All right. Remember, I did talk about this today. And all right, you guys, yeah, you're right. Long and thin. In fact, I'm going to write that out. Long and thin. All right. Think about it this way. You're walking down the hallway. I use the example in some classes about the bridge to the T&I building, right? If this was the hallway to the T&I building, you'd be moving so slowly because you'd have a lot of resistance. All right. You want to go through a hallway like letter D. All right. Letter D has like the lowest resistance. It's short and it's thick. It's the longest. The wire is going to allow just electrons to just flood through it. Letter A is the opposite. It's thin, so it's going to be a narrow pathway for the electrons to follow, and it's a long pathway. So most resistance is long and thin. Okay. Least resistance is short and thick, like I mentioned today. All right. Winter, spring, March, swinter. For some extra credit points, which season is your favorite? Type it into the chat. And we'll do 20 seconds. 20 seconds. And this is something you got to type in there. So I was talking about at the beginning. It's one thing to watch the live stream review. It's one thing to have it on in the background while you do other things. But you got to be involved. Oh, there's a timer. Awesome. You got to be involved with it. It really is more helpful if you pay attention and if you see it. Awesome. You guys are awesome. So I expect as many replies when I ask a question like this one. Because if you're engaged with it, there's going to be more things in your brain firing and you're more likely to remember this stuff. So series or parallel, which one is it? There is only one pathway for the electrons to flow. So A, B, or C. Is it either one? And I'm telling you, get it, like put an answer or something. Write this down. Maybe you don't have to put it in the chat, but do something where you're not just sitting there watching it and maybe have something else going on. You know, don't make this the background. Make this is the foreground. It's only going to be like 20 more minutes maybe. All right, you can do this. It's an investment. All right, one pathway. Yes. All right, you guys both got it, or you both got it. Who said it? That's a series. That's like the definition for a series circuit. It's one pathway. All right, so that's like the single loop. Series or parallel? When a new bulb is added, the other bulbs get dimmer. Oh boy, that's like one of the first labs we did, right? You had to add the light bulbs. You had to compare their brightness. Series, parallel, or either. That was a crazy lab. Not really. It was just one of the first ones we did. All right. Yeah, you guys are getting it. Yeah. All right. For sure. It is series, because every time you add a new bulb, which is a resistor, you're adding, every time you add a new bulb, you're adding, oh, my nose itches. Every time you add a new bulb, you're adding resistance. So every time you add resistance, it slows the whole operation down. It slows the entire circuit down. So everything gets dimmer. There's just not enough energy to go around, okay? Because the battery is trying to push through all of it at once, and it's not easy. All right, series or parallel, each resistor has the same voltage as the total voltage. Don't touch your face during live streams, ladies and gentlemen. It just is not good habits. It doesn't look, it's just one of those things that bothers people. Okay, this one's a little tricky, honestly. I could see, I'm gonna wait for an answer. Some brave soul. Okay. Good. Did you get a haircut? All right, I'm gonna answer this question first. The answer is B. Okay, I said it's a little tricky, but it's not the same voltage as the total voltage. All right, you did this. It's where it's parallel. I mean, again, that's one of the easies about parallel. No, I did not get a haircut. I gave myself one last haircut, one last COVID haircut. Next time I'll go to a barber. So yeah, it was getting a little long again. All right, series or parallel, when one bulb goes out, the others remain on. When one bulb goes out, the others remain on. Series or parallel or both. Good. Good. Yes. So because there's multiple pathways, like is this light bulb? We'll use that as a symbol for a light bulb. That'll work. So, so those are light bulbs. Over on the left-hand side is a battery. Let's just rehook that up. So basically, because of the multiple pathways, if this one gets eliminated, the electricity can still go around and through the other light bulb. So that's why it's parallel. Very good. All right, like I said, I hope you're paying attention, maybe writing these down or something, because you'll see similar questions on the test. Series or parallel, the current through each resistor is the same. every time. Through the resistor, through the battery, everything, through everything is the same. The current through everything is the same. Good. I hope this is ringing some bells and making you feel a little bit better about this test. All right, it's not all solving those crazy circuit things. Good. Yes, in a series circuit, the current anywhere is the current everywhere. All right, and we're going to see that again when we come back to when we do that. When we do go back and solve those circuits. That's like the easy for a series circuit is the current anywhere is the current everywhere. Series or parallel? Can a switch that turns off some lights but not others? It can have a switch that turns off some lights but not others. These particular questions should look familiar to you, by the way. They may or may not be directly from the review guide. But there's only so many ways to ask these questions, you know? So, Martin, I don't even know what you're, man. All right. All right. So yeah, the answer is B. I'm guessing some of you guys are going to write B. Somebody's going to write B, but we'll see. Oh, maybe not. Yes, parallel. You can have a switch that turns off some lights but not others. Your house is wired in parallel. You have light switches that can open up some circuits but not others. Now, there's nothing to write here, but I just wanted to show you this because I found these the other day, which is kind of crazy that I only just found them because they're literally, I think, from the 90s, apparently. Come back. And I lost my, here we go. It's an animation that's just, it's an analogy for high voltage and low voltage. But instead of being high voltage or high electric potential energy, it's showing you using high gravitational potential energy, which it's very similar. It's stored energy is what it comes down to. It's higher energy. So here we have these little positive like marbles, and they get to stay on the track. The battery or the pump lifts these marbles up to a higher potential, in this case a higher gravitational potential. So now they have this energy stored, this stored energy, gravitational potential, and they follow this path. They magically don't fall off the path, so they're high voltage, and then they come down. There's a resistor here, and in order to push the resistor, it has to roll down these. They have to roll down these hills and lose that potential. So now we're back at low voltage, and there's the battery, and it pumps it back up. All right. Here is that diagram from earlier, along with basically a diagram showing the same thing. So on the left is the circuit diagram showing the battery, which gives these electrons a high voltage or a high electric potential. And then the electrons can, this is a parallel circuit, so the electrons can split and go either way. And then they come back together and they're at low potential. So basically what's happening is the battery, remember, it doesn't supply the electrons. The electrons are already there. It's just part of the conveyor belt system or whatever that lifts the electrons or the charges up to a higher energy level and high voltage, in this case, high gravity, you know. And so why do these electron balls roll down the hill? Because they're high up. Why do these electrons go through the light bulb? Because they're high up, but instead of being gravitationally high up, they're electrically high up. They're electrons that have been pushed together and they're repelling each other. So they have a high energy. So these roll down the hill and they roll down the resistor. Now, Danny earlier mentioned a short circuit. What if one of these resistors was removed and you still had a connection? Well, then no marble is going to go down the side that has a resistor on it. It's going to go down the easy path, and they're all just going to roll down the path with no resistor super duper fast. And they're going to start moving so quickly that they're going to wear out the track or burn the wire out. Okay. A few more. Yes, your emojis are amazing. This one does show the same thing. No, there's no color here, but it does. See, look at 1998. Like, where was it? Where have I been all these years? I didn't even notice. They're kind of terrible, but they get the job done. So the battery lifts up the electrons to higher potential energy. In this case, gravitational potential instead of electrical potential. And the 30 ohm resistor moves, they're moving slower because it's 3 times the amount of resistance compared to the 10 ohm resistor. You can see they're moving a little bit faster, probably 3 times as fast down this hill here, because this little spinny turny thing is 3 times harder to move. This one over here, the 10 ohm resistor, it spins pretty easily. And so more marbles are going to roll down this hill than can roll down this hill, just because like they can't get through this as fast. They just can't move through it as fast. It's the same thing in a circuit. That was parallel. This is in series. So it's the same idea. The battery lifts it up high to a higher energy level. And then the electrons are forced to follow this path. I thought they were kind of nice. I thought they were very useful. We'll put it this way. And they had to roll through here, and they had to then roll through here. And so you can see they lose energy, they lose electric potential energy, they lose voltage when they roll through one resistor. And in order to roll through the second resistor, they're going to have to roll a little bit more down the hill. And then it repeats over and over again. And these analogies may or may not be useful to you, but I thought, they might be. This is what's called a combination circuit. And I just threw this up there because things could get pretty complicated, but I don't want to really talk about too much. But the idea is batteries just pump the electrons to a high voltage, okay? They don't pump them up a hill, but they pump them so that they're crammed closer to each other, So they're trying to get farther and farther away. Why can squirrels and birds and stuff land in high voltage power lines? You don't have to answer this. Well, actually, you should know how to answer. This is from the review as well. But I wanted to use this diagram to show you why. So on the review guide, here's the thing. Let's say you were standing up top here. You just had both feet and you were standing up on top of the hill. Is there any reason that the electrons are going to roll through your body? No. Both your feet are up high. So there's no reason for the electrons to flow through your body because there's no potential difference. There's no voltage between your 2 feet. And so there's no push for the electrons to go through the bird's feet or the squirrel's feet. There's no potential difference between their 2 feet. That's what it basically boils down to. But the government drones, I never heard the charging part. Yeah, that's an interesting little theory, but one of those crazy conspiracy theories. All right, are there any questions about 7.1 Ohm's law? Not Ohm's law, just the circuits, series, parallel, that kind of stuff. I'm going to get into all that stuff in a minute, but all right, let's move along then. Ohm's law. What's the resistance here? Now this one you might not know how to do off the top of your head. If you did the review guide, I hope you do remember how to do it. But this is one of those things where it's like, oh, I'm so glad I watched the review live stream because Mr. Journey showed us what to do with these graphs. What is the resistance of this? Well, you don't actually, don't put it in the chat. Well, actually, if you get an answer, go ahead and put it in the chat when you get the answer. And the answer is, well, I'm going to tell you, I'm going to work my way through it. When you have oh, hey, it got cut off. Let me just try something really quick. On my PowerPoint, the bottom's not cut off, but on your screen, it is. So let's just do this. I hope that works. All right. That looks better. Okay, now we can tell it's actually got voltage or current. So we got voltage and current. And whenever you have a voltage versus current graph like this. The slope of the line is equal to resistance. Holy cow. What in the world? All right. Let's see if we could undo that. No. Okay. I just pressed a button. All right, but that's the idea. I'll write it down again. The slope of the line. Here, let me just. I gotta do something. The slope of the line is equal to resistance. So I'll rewrite that and hopefully not have the weird jankiness happen again. In fact, I'll write it in a different way. Resistance is equal to the slope. All right, so if you can find the slope of this line, then you'll find the resistance. And this line looks like it's going to go through 0, 0. So slope, and this is on the equation sheet if you forget it, slope is equal to y2 minus y1, that's y1, divided by x2 minus x1. On the equation sheet, in case you forget it, your best bet is if it looks like it goes through 0, 0, use 0, 0. So that'll be 0, 0. And this will be your x1, y1. And then you want to, I'm just going to pick, you don't want to pick a dot. You want to pick something, you want to pick something on the line. So I'm going to pick 0.8 voltage. And if I look at that down, it didn't work. You mean the slope? Well, let's see what I get. Okay, because it might not be perfect. So let's see. So I'm going to do my second one is going to be 0. So this looks like it might be 0.7. So maybe 0.75, comma, and then my y value is 0.8. And I'm guessing I think I know what happened, Elizabeth. So let's try this out. Let's see. All right. So this will be my x2 and y2. Okay, now, do you have to do all this? I think so. I mean, if you want to get the question right, you want to make sure you do this right, do this, right? So 0.8 for my y2 minus y1 is 0, divided by 0.75 minus 0 for my x2 and y2. And so I'm going to get 0.8 divided by 0.75. I put that in my calculator. 0.8 divided by 0.75. I get 1.066667. So let's just write that down. 1.0667. Okay. Mr. Jern, that's not one of the choices. Well, it is. Pick the one that's closest because look at this is a graph and you're not going to pick the perfect. There's no such thing as a perfect thing to pick. Okay. Especially when you get real data like this. So find slope and choose the choice that's closest to it. Okay. So Elizabeth, I don't know if that's what happened, and you were just like maybe you chose slightly different numbers, and that's bound to happen. Okay. All right. So 1.1 is going to be the resistance because of resistance is equal to. That didn't go very well, but resistance is equal to slope. So now it's fair game for me to ask this kind of question. How much current would there be if voltage was 5 volts? Well, oh, it's a graph. Let's just look at the, oh, it doesn't go up to 5. It only goes up to 1. Or maybe 1.2 because I cut off the top of this. All right, maybe it goes up to 1.2. Okay. Well, then is that the answer? Is it letter D? No. No. It's not letter D. Here's the deal. Remember, resistance is 1.1 ohms. Okay. That's from the, we already figured out resistance is here from the slope. Resistance is 1.1 ohms. We got that. Previous question. We want to know how much current is there if the voltage was 5 volts? You might want to look at the equation sheet and see that I is equal to V divided by R. And if, because look at, we got current, which is I, we got volts, which is V, and we want to find we want to find current, and we've got resistance, okay, by finding the slope. So then all I got to do is maybe, yes, I think it is. I think it is 1.2, if I remember correctly. So we take the voltage, which is 5 volts divided by the resistance, and oh, maybe not. Maybe not. 5 divided by 1.1. I think it might be A. 4.5. Yeah, it's A. It's A. So, all right, and that'll be in amps. But you see what I did there. So you can find resistance. I'm going to try to write diagonally. Resist is equal to slope. Okay, that's like when you see a graph like this, just remember that resistance is equal to slope. I know that's what you said. That's what you meant. But that's like the big takeaway from these things. And once you can get resistance, then you already know voltage, you already know current, and you've got the 3 things that we really worry about in this class. Yes, Troy, this will be, yep, you get extra credit. And yes, everybody, this will be on my YouTube channel if you need to finish it later. All right. So, cool. How to solve for current. You guys got this one. You know it. You just saw it. It's a freebie. Come on. Oh, I gotta wait 10 seconds. I'm sorry. I feel like it's been 10 seconds. When in doubt, check the equation sheet. All right. Many of you were able to pick up the paper copy today. The answer is, yep, it's where my little pointer was hovering. It's B. All right. How to solve for current? Good, good, good. All right, you guys are great. Maybe it's longer than 10 seconds now. I don't even know anymore. Current is capital I. I mentioned it in class. Check out the notes. It will, it'll remind you about all these letters, okay? The very first question on the review guide was to solve that data table with, or that table with all the letters. If I could say anything about that, check the key. Make sure you are correct. Okay, don't assume you are correct until you check the key. For that first question, if you could get that first question with all the like, what is the letters for current? What's the letter for amperage? What's the symbol? What's the unit? If you get that one thing, then if you sit down and think about it, you can figure out like almost everything else. Because, excuse me, because if you know current is capital I, then all you got to do is look on the equation sheet and you'll see that B is correct. All right, the other ones are nonsense. The other ones, those are wrong, and they are definitely not the same. What is I? Maybe I should have put this slide a little earlier in the little live stream review. Oops. But seriously, what is I? Don't overthink it. It's like 25 seconds for me. No, it might not be you. I don't know what the delay is. I did this yesterday, or I did this a couple days ago, and I thought the delay was like 10 or 15 seconds, but the delay might be a little longer. Apparently it is. All right, yes, you are correct, guys. I is current. Okay, that's what I was talking about, that first question on the review guide. What is A? The delay is not bad, though. It gives, well, it's fine. I'm going to see if I can get rid of that delay a little bit. No, I can't. But you know what? I don't want to mess with it. YouTube gave me some options, and I chose the middle ground. All right. All right. A stands for amps or amperage or amperes, not ape. amperes. Spell. So if you see, yeah, if you say like 50A, that's amperes, and that means current is 50A. All right. Exactly. Well, again, that's one of those. Like I said, you see 45A, you got to know that right away. Boom, that's current. Okay. A stands for amperes. What's V? Is this one insulting? I feel like this one might be insulting. All right, you know what? I know there's a delay. Yeah, V is voltage. I put it there not to be insulting, but I put it there because it is possible to overthink this. All right, V is voltage, volts, whatever. All right, I'm just gonna move on. R, what is R? Don't overthink it either. I'm gonna attribute that to the delay. All of these. My fault. I moved on before I waited. I didn't wait for your reply. So you bet. All right, take care, Maddie. Yeah, like I said, this will be on YouTube later. So I'm going to do the circuits. I'm going to solve a circuit and all that. All right, good. R, resistance. What is P? Ooh, what P? What is it? Power? Does it stand for power? That would make a lot of sense, but sometimes this unit doesn't make sense. Awesome. Is it power? P stands for power. Don't overthink some of these. Some of these are weird, but don't overthink them. And like I said, no, you're wrong. Like I said, some of these are, okay, here's, this one I would call, like, you should definitely know this. However, yes, it was D. This delay is crazy. I would end and restart the stream, but I think we're probably okay. So what is ohms? Yes, ohms. What is ohms? So I'm going to do a thing I could see myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13-second delay. All right, 13 seconds for me. So good. Yes. Oh, wait. Yeah. This is resistance. Good. All right, fantastic. Good. Yes. So you would see like 50 ohms, and that would be R, resistance. So 13-second delay I counted. All right. What is W? I don't see that one a lot. Well, you did. You should have. Actually, you do see it a lot. You see it on a lot of things. Usually you see the word spelled out. Well, not all the time. There's not a lot left of this, by the way. Okay. Fantastic. Yes, it is P for power, also known as choice D. P is power. So if you see like 50 W, that's 50 watts, and that would be P for power. Fantastic. So right, the W is the units, and this is the P is a symbol. Okay, instead of writing out the word power every time and watts, you use the symbol or the units. All right, how to solve? Wait a minute, Mr. Jern. All right, don't answer that last one. A pool filter rated for 1,119 watts draws 5.1 amps of current. How much voltage is required? I want to do one of these on this review. Give you a chance to show you how to do this. It involves the 4 steps. You could guess, but you risk being wrong. All right. Really quick. do yourself a favor and do the 4 steps. Whenever you see a question like that, I don't know how else to tell you. I know you could do without it, just plug in your calculator, but seriously, you do risk getting it wrong. Many of you guys have been showing me this beautiful work that you've been doing, and it looks great. Don't not do that for the test, okay? So 1,100, hang on, it says, let me just, here, I'm gonna scooch this over here. So watts is power. So power is 1119 watts. Amps is current. And it wants to know voltage. Okay. So you got that far. You look on your equation sheet. Now there was a question on the review guide that asked about this, but it didn't give you something. You had to actually calculate it doing something else. So if you get to that question, you're not sure how I did that, let me know. It is on the key. There was a second step there, but that one was sort of a challenge question. This is a little bit more straightforward. You look at the equation sheet and you're gonna see that PIV, P equals I times V, okay? It involves these 3 variables, which is why you've got to list them out. It really helps. But we want to solve for voltage. And so what I'm going to do is I want to get voltage by itself by dividing current out on the one side. So that means that voltage is going to be power divided by current. So, yeah, power is 1119 divided by current, 5.1 amps. So voltage is equal to, I think I know the answer, but I want to make sure. 5.1, 219.4. So I'm going to write it just like that. That'd be volts. The final answer, just put it. And so the closest answer to that is B. Nobody said B, but I don't think anybody was. That's okay. That one. So again, I just wanted to walk you through one more, solve it using the 4 steps. Okay. Okay, we're at 45 minutes. I think we're gonna make it to I think we're gonna be under an hour still, but I'm just saying. I mean, hopefully you find it worthwhile here, because gotta do some of these. I think that'll be it. And like I said, if you got questions, I can always go back. Okay, there's the 13 or 15 second delay. So if I don't see it, it's not your fault. It's not my fault. It's just the delay. All right, how do I do this? What's the voltage here? All right, my advice to you when you see a question like this is do the entire chart. All right. So you know what? I'm not gonna. So if you remember V, I, R, I don't know if we need to do power. Let's not do power. Okay. And I'm just going to set it up a little differently because I'm kind of lazy. Not lazy, but I'm going to do the total. I'm going to do the resistor 1, 2, and 3, I guess. I'm not lazy. I can't draw very well. I'm not gonna lie. And so okay. So this is the total. So it's very similar to what you've been doing, but I would just make the chart. If you want to include P, you can, but that's up to you. So then what I would do is the steps. So I'm going to write down, all right, V equals I times R. I'm going to write down I is V over P, V over R, holy cow. And what are we missing? VIR, or resistance, is V over I. So the 3 equations. I don't know if I need to worry about power, I will worry about power in a minute. All right. So then I'm going to do the givens. So the total voltage is 9 volts. The resistors are 5 ohms, 10 ohms, and 15 ohms. Okay. This right here is what I'm trying to figure out. Okay. Voltage across the number 3, the 15 ohm resistor. And then I'm just going to do the thing. I'm going to have to solve it. So over here, I think you guys can see my little cursor moving around. I can't do any of these things because I don't have enough information. But what I can do is solve for the total resistance. This is a series circuit, okay, which means that the total resistance is equal to R1 plus R2 plus whatever other resistors there are. So it's literally 5 plus 10 plus 15 gives me 30 ohms of resistance. All right. Stop me if I'm going too fast. I know there's a delay, but I'll go back. From that point, I could figure out the total current because now I have 2 of the 3. And so I'm going to use this equation right here to solve for current. I'm going to take volts divided by resistance. So 9 divided by 30. I don't think I need to put my calculator up there, but let me know if I do. So 9 divided by 30, I got 0.3 amps. Okay. Now, because of that, my easy is I've got current coming out of the battery is 0.3 amps. And it's a series circuit, so that current is also going to go through that resistor, and all the way around. So that means this is 0.3, this is 0.3, and this is 0.3. Got it? Now I can figure out the voltage through the 15 ohm resistor, because voltage is V equals I times R. So if I take 15 times 0.3, the voltage is 4.5 volts. So that's going to be my answer. Guess I should have done this the rectangle, but all right. So the takeaway from this is if you see a question like that, that's worded like that without the chart, just do the chart. All right. If you need to figure out the other 2 voltages at some point, then you can. You know I had to do this. And this will be the last thing we do. Hopefully it's helpful. What is the current through the 15 ohm resistor? Oh wait, what's the total resistance? And then what's the current through the 15 ohm resistor? I got a double question here for you. The reason is I want total resistance. You knew I was going to ask this because I had to, because some of you guys need a lot of help with this. Okay. I'm still going to like kind of set up a little data table for myself. All right. Now, this is not like meant to be neat. V, I, R. This is just meant to sort of organize things in a way that will work. So V, I, and R. And then we got, I guess, the total. We got resistor 1, 2, and 3. So just to help organize, doesn't need to be perfect. Okay, so I'm going to write total here just in case like we're not sure what that is. We want to know the total resistance first of all. Let's do the thing. So the givens 9 volts, and we've got a resistance of 15 ohms, 5 ohms, and 10 ohms. Okay. Oops, that line didn't need to be there. What is the total resistance? Okay, on the equation sheet, I think it's written like this. Oop, hang on. Let's do this. R equals V over I. V is equal to I times R, and I is equal to V over R. Okay, so we got our 3 equations, and I'm pretty sure this is how it's written on the equation sheet. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus whatever other resistors there are. That's for a parallel circuit. Okay, and that'll get you the answer. So this is meant to be a T, not a 5. And what that means is when, here, let me show you what it means. So what that means is this. 1 over the R total is equal to 1 over 15 plus 1 over 5 plus 1 over 10. Okay, when I do that, I put it in my calculator, And you could do this either way you want to. Okay, you can also put whatever you're used to by now, but I'm going by what's on the equation sheet. Why did I switch? I started clicking for no reason at all because I want to put my calculator up there. So here's my calculator. Let me just scrunchy face that down a little bit. So actually, you guys aren't saying anything right now. So I'll do this. Let's get this focused a bit. Okay. So you can just do it like this. Parentheses 1 over 15 plus 1 over 5 plus 1 over 10. Okay, and you're, whoa, yeah, I just saw that as I was hitting enter. What did I do? Plus, and then I got to delete that. Okay, so 1 over 15 plus 1 over 5 plus 1 over 10 gives me that answer. Now that's not the final answer. Okay, that's 1 over our total is 0.3667. So what I need to do then is take 1 over that. So our total will be 1 over 0.3667. Okay, so I'll do 1 divided by, I like to just do the answer. So my total resistance is 2.72 ohms. That said, I'm going to show you one more time the way I like to do it. I totally got rid of everything. I like to use this x to the negative 1, the inverse button, and it might look different on your calculator. It might be in a slightly different location. That way I could just do 15 inverse, which is the same thing as 15 over 1, or 1 over 15, plus 5 inverse, plus 10 inverse, and there's my 3.66667. And then I just take the inverse of that, and there's my 2.72. See how I add way fewer buttons, less likely to make a mistake, because you saw I made that mistake, actually. That was not intended. So I make that mistake, and that's not good. Actually, I'm going to scooch that over just in case. Covered his chat. Yes. Now I uncovered it. I think there's nothing down here, so I'm just going to leave the calculator right there. No, you can't. See, there's a 15-second delay. You'd think you're so smart, but you're not. So either way, the total resistance is 2.7. I'm just going to put the 3 in there, 2.73 ohms, because I don't like rounding until the very end. You've lost the power, sir. Power is I times V. Okay, so that's the first question. 2.73, it's supposed to be a decimal, ohms. Okay. Looks like the state of Nebraska or something. What's the current through the, okay, so not seeing anything in the chat. Hopefully you guys are okay with that. There's different ways to do it. So what's the current through the 15 ohm resistor? Well, one other thing that I forgot to mention is we could do this. The easies is 9 volts, 9 volts, 9 volts. What's the current through the 15 ohm resistor? Well, we just have to use this equation right here, V divided by R. So I could take 9 divided by 15, and that's the current through that resistor, 4.6 amps. Okay, and I can do the same for any of those, but I guarantee you, ladies and gentlemen, you're gonna have to find R total on the test. It is what it is. It's one of those questions. It's like, gotta know how to do it. Are there any questions? I'll leave this up there. If not, that's all I have. Okay. I'll wait like another 30 seconds or so in case you do have one. Or if you want to just like type yes question, and then type your question, you can do that. All right. Well, like I said, I hope today was useful. I think I have anything else. Yeah. I hope today was useful to you. Like I said, it was in a little format that was a little bit easier to hopefully deal with, but that's it. So I'm not seeing any questions. If you do have any questions before you take the test, just send me a question over Remind, and I'll answer it as best I can in the time that I have. All right. Go to bed at, like, you know, I mean, maybe don't send any reminds after 9:30. I probably won't get around to answering at that point. We'll see though. All right. You guys are awesome. All right. For some reason, Omar, there's a bunch that got flagged. Some of you guys' chats got flagged. I had to actually show them. Interesting. All right. We'll talk. We need to talk about that kind of stuff. I don't even know. All right. Well, I'm gonna end the stream though. I'll talk to you guys tomorrow. I'll see you then, and good luck. Bye.